Okay, so today we're going to focus on graphing rational functions, and there are some notes on the board that will help you in case you don't remember your notes to help us figure out kind of your vertical asymptotes, your holes, and things like that. So we have 3 problems. They're all a little bit different from each other. So here's our first problem. F of x is equal to 2x plus 7. Divide that by x plus 3. So take a moment, copy that down, and we're going to go ahead and we're going to solve this problem. So the first things I want to do is I want to figure out my points of discontinuity, any holes and any asymptotes. So I want to take a look and I want to see if I can factor anything out. Between a 2x and a plus 7, there's nothing to factor. X plus 3, there's nothing to factor. So there's nothing in common between my numerator and denominator, no binomials. So that means for my holes, I have none. So the next thing I want to find will be my vertical asymptotes. So my vertical asymptotes are will be anything in my denominator I'm going to set equal to 0. So I have a vertical asymptote at x is equal to -3. The next thing I want to find is my horizontal asymptote. So I'm checking out the exponents of my highest degree, power 1, power 1. So they're the same. So when they're the same, you divide your coefficients by each other. So I'm going to be dividing a 2 by a 1, which is y is equal to 2. Asymptotes should be lines, not just numbers. So please make sure you write them as such. If you have a horizontal asymptote, that means you do not have a slant asymptote. So we can write none. I want you to get into the habit of writing all 4 of these things out. Once you find these 4 things, the next thing I want you to do is I want you to find the x-intercepts and y-intercept. So the x-intercept is where your graph is going to cross the x-axis, which means your y is going to be 0. So I'm going to replace all of that with a 0. Okay. I'm going to cross multiply. And I'm going to solve for x. And please make sure to write your coordinate as an actual coordinate. Once I find my x-intercept, then I'm going to find my y-intercept. So remember, my y-intercept is where it crosses the y-axis, which means everywhere I see an x, I'm going to replace now that with a 0. So f of 0 is equal to 2 times 0 plus 7, all over 0 plus 3. Let's go ahead and simplify. 0 plus 7 is 7. 0 plus 3 is 3. So f of 0 is equal to 7/3. Again, write this as a coordinate, 0, 7/3. All right. Now, before we can state our domain and our range, right away, I kind of want to see what this graph looks like. So I pulled this up onto Desmos.com, and the first thing I'm going to do is I'm going to write down my vertical asymptote and my horizontal asymptote. So here's my Desmos. There's my horizontal asymptote, dashed line. Sorry, that's my vertical asymptote. And that is my horizontal asymptote. Now, I would be plotting these points. I'd be plotting -7/2 and 0 7/3, right? 0 7/3, okay, is going to be somewhere above here. And -7/2 is going to be somewhere down here. So that would dictate kind of where my graph is going, right? So I plot those points. And I can always plug in some other points to the right and left. But here's what my graph is going to look like. So notice that my graph kind of hugs and curves around your asymptotes. So take a moment to pause if you want to pull this up onto your Desmos.com to see what it looks like yourself. That's fine. All right. So how do I write my domain and range? Well, basically, you're seeing that the graph keeps going on and on forever and ever that way. And it goes on forever and ever this way. But there's only one x value that it's never going to be, right? And that's your asymptote. Same thing. We notice that it continues from -infinity all the way to +infinity. But it looks like there's one y value will never be. So how do we write our domain and our range? Our domain will always start with -infinity. And you are going to go to the first point of discontinuity, which was -3. We had an asymptote there, so I'm going to close that up. But I'm going to start again at negative 3. And I'm going to go to positive infinity. So basically, x cannot equal negative 3, essentially, is how we can also write it. For our range, okay, same thing. Our range can be any number except for 2. So we are going to say our output is negative infinity all the way to 2. Union that, 2 to infinity. Again, it's like saying y cannot equal 2. All right. Take a moment to pause this video and to record anything into your notes that you will need. Okay. So let's do another problem. All right. So here's our second problem. So x squared plus 3x plus 2 all over x squared minus 1. So the first thing I'm going to do is I want to factor this because I notice I have trinomials on the top and on the bottom. So my denominator is a difference of 2 squares. So this will become x minus 1 and x plus 1. And in my numerator, I have an x plus 1 and an x plus 2. Okay. Now, what am I looking for? I'm looking to see that there are binomials in common. Notice that I have a binomial in common right here, x plus 1. So this is the start of telling me that there is a hole in my graph. Okay. So I'm going to set the binomial that's in common with each other equal to 0. I'm going to solve for my x. And that's my x coordinate of my hole. I need to find my y coordinate of my hole. So what do? I'm going to simplify this problem. I'm going to take away x plus 1s. And so I simplify it to x plus 2 all over x minus 1. Because if I plug a negative 1 back into this equation, I'm going to get a 0 on the top and a 0 on the bottom, and that's going to be still undefined. But if I plug a negative 1 into this equation, it won't be undefined anymore. So everywhere I see an x, I'm going to plug in negative 1. So this will become f of negative 1 is equal to negative 1 plus 2, negative 1 minus 1. So 2 minus 1 is 1. Negative 1 to negative 1 gives you negative 2. That is your y coordinate of your hole. So your hole is a point, and it does not exist negative 1, comma negative 1/2. So if negative 1 is a hole, that means everything else in my denominator that can equal 0 is a vertical asymptote. So the only thing left is an x minus 1. I don't see an x minus 1 on top. So I'm going to set x minus 1 equal to 0 and solve. So I get a vertical asymptote at x is equal to 1. Now for my horizontal, my horizontal asymptote. Okay, I go back to my original equation. I have an x squared and an x squared, so they are the same. So again, I'm going to take my coefficients and divide them. So 1 divided by 1 leaves you with 1. I have a horizontal asymptote, which means automatically I do not have a slant asymptote. So I can write the word none. I'm still going to find my x-intercepts, just like I did before. So x-intercept, I'm going to replace this whole equation. 0 is equal to, right? Replace all of that. So x squared plus 3x plus 2 all over x squared minus 1. So it's going to look something like that. Cross multiply. So 0 times that is just 0. Okay. And I notice that it's, again, trinomial. So how do I solve trinomials? I have to factor it. Set them both equal to 0. X is equal to negative 1. X is equal to negative 2. Now, issue. Notice that I have an x-intercept at negative 1. Notice that I had a hole at negative 1. Can I have a hole and an x-intercept at the same place? No, because that wouldn't be a function. Remember, you're graphing rational functions. So the point, negative 1 comma 0, does not exist. It's not going to be there on our graph. But negative 2 comma 0 will be there on our graph. Okay. So now we move on to the y-intercepts. So again, I'm going to say f of 0 is equal to So it's going to be a 0 squared, which is 0, plus 3 times 0, which is 0, plus 2, all over 0 minus 1. So this will become f of 0 is equal to 2 divided by negative 1. So 0, comma, negative 2 is our y-intercept. So again, now before we state our x-intercepts and our y-intercepts and our domain and our range, let's see what this graph would potentially look like. So the first thing I want to do is I want to plot my vertical asymptote and my horizontal asymptote. So I'm going to replace x squared. X is equal to 1. Y is equal to 1. And remember that I had a hole at negative 1 comma negative 1/2. So technically, I would be graphing this. Here's negative 1, and a negative 1/2 is probably somewhere right about here. I would be drawing this as a little hole right here. Okay. Now, unfortunately, Desmos cannot do that. Okay. So we'll have to imagine that there's a hole. I'd also be plotting my x-intercept. So my x-intercept will be at negative 2 comma 0, and I'll have a y-intercept at 0 comma negative 2. So this whole graph on this side is not going to cross it. So you are going to need to plug in points. I might want to plug in 2, 3, just to make sure that I know I'm graphing on this appropriate side. All right. Make a table. And then here is our graph. So again, notice that we have negative 2 comma 0, 0 comma negative 2. And if I go here, notice that it says it's undefined. It's a little hard to see over my cursor, but you can tell that there's a hole in this graph. Okay. Now, how can I pick a point on this side? Right? All you're going to do is you're going to pick, say, 2. Right? Or so, yeah, 2. So we know 2 gives you about, what does it give you? 4. Okay, it gives you exactly 4. So that kind of tells you that you're roughly over here on that side. How would I actually be figuring this out? Well, everywhere I see an x, I'm going to replace it with a 2. So 2 squared plus 3 times 2 plus 2 all over 2 squared minus 1. So 4 plus 6 is 10. 10 plus 2 is 12. 4 minus 1 is 3. And all of a sudden, you got a table of points. All right? When in doubt, table of points. So how do I state my domain? Okay? So my domain always starts at negative infinity. So I have, my graph is going. Stop. There's a hole. I got to jump. So that's my first point of discontinuity right there, at negative 1. And it keeps going until I get to my vertical asymptote. So how do I write that? I write it as negative infinity, comma, negative 1, close that up, union it, negative 1 to positive 1, oops, positive 1, close that up, union it, and there's nothing else after 1, so it's just going to go forever until it hits infinity. How do I make my range? All right? So again, think about it. It's going up and up and up and up and up and up and up until it hits that point. Discontinuity has to jump. Going to union it until it gets to 1, and then it jumps, and then it keeps going up forever and ever. So we're going to do exactly like we did here. So it's going to look like this. Negative infinity, all the way to a negative 1/2. Stop. Union it. Start again. Negative 1/2 to 1. Stop. Union it. 1 to infinity. And we're done. Okay, so these are basic graphs that we've done before. Okay, and here's our last type of graph that we are going to see. We're going to see a slant asymptote on this one. So that way we have in our notes examples. Okay, so x squared plus 6x plus 8 all over x plus 1. Okay, so again, the first thing I want to do is I want to factor anything in my numerator and denominator. I can't factor anything in my denominator, so I'm going to leave it as x plus 1. But in my numerator, I can make it x plus 4 and x plus 2. Is there anything in common? No. So we do not have any holes. So hole, we have none. Vertical asymptote. Anything in our denominator, set it equal to 0. I get x plus 1. So x plus 1. Set that equal to 0. X is equal to negative 1. Horizontal asymptote. Now notice, numerator, denominator. Numerator has a higher degree than your denominator. So this time, looking at your notes, there is no horizontal asymptote. So none. But we wrote down for slant asymptotes, your numerator needs to be 1 higher than your denominator. 2 is 1 more than 1. So yes, this has a slant asymptote. So how do we find your slant asymptote? You are going to do long division. So this is good practice for your final. So I'm going to put x plus 1 on the outside. Then x squared plus 6x plus 8 underneath. What times x gives you x squared? X. Multiply that, so x times x is x squared. X times 1 is a positive x. Subtract, subtract. That goes away. 5x. Bring down the 8. What times x gives you 5x? Positive 5. So that will give you a 5x. And then a plus 5. Get minus, minus. That goes away. You're left with 3. Remember, slant asymptotes, we don't care about the remainder. Doesn't matter. We only care about our line. Here's your slope, and here's your y-intercept. So technically my SA is a y is equal to x plus 5. So it's going to be slanted instead of vertical or horizontal. It's slanted. Okay. We still want to find x-intercepts. X-intercept, I'm going to set this whole thing equal to 0. So 0 is equal to, and I'm already going to set it equal to the factors. Hopefully you've caught on that basically for x-intercepts you're just setting your numerator equal to 0. But if not, you'd cross multiply. And if I set this equal to 0, I'm going to get negative 4. And I'm going to get negative 2. So negative 4, comma 0, negative 2, comma 0. Okay. Next thing, y-intercepts. So I'm going to, everywhere I see an x, I'm going to replace it with a 0. I'm going to go back to my original equation for this one. So f of 0 is equal to 0 plus 0 plus 8. And then 0 plus 1. All right, so f of 0 is equal to 8 over 1, which is just 8. So I can have it 0, comma 8. So I have my x-intercepts. I have my y-intercepts. So what am I going to do? I'm going to graph. Okay. So the first thing I'm going to do is I'm going to graph my vertical asymptote. So there's my negative 1. I'm going to graph the y is equal to x plus 5. So it's going to look like that. So your graph is going to be somewhere in between here or somewhere in between here, right? Those two graphs. Okay, so that's why you can have two x-intercepts. So I have an x-intercept at negative 4. I have an x-intercept at negative 2, which is right there. That was 1 over. So negative 4, negative 2. So it's going to be coming up and then going right back down. Okay, and then over here, right, it should be crossing your y-axis at 0, 8, right? And so your graph is going to be coming here and then going off, okay, in this direction. So we already have, that's the beauty about x-intercepts and y-intercepts. It will already help create your graph. So here is what your graph looks like. Okay, on these problems, we're not going to find the range. We'll just state the domain because without a calculator, you're not going to know exactly what that point is. The highest y value over here or the lowest y value over here. And we're not going to find that out either in this class. So we're only going to state the domain. So the domain, my smallest value is negative 1. Okay, and if you think about it, I can plug in any number in for x except for negative 1. Stop, union it, -1. And then notice my graph continues. So -1, I'll be able to plug in all the numbers. They're just going to start going up and up and up and up and up. So all the way to infinity. Okay. Now, I put a couple of challenge problems on there that I did not show you on this video. So when in doubt, pop it onto Desmos and see if your graphs look like what they're supposed to look like that you graphed. Okay. They're towards the end. And if you have issues, email me.